So hello everyone, and today we are back with a question from CSIR NET 2020 which was held on 30th November, and the question again is from the ordinary differential equation subject and from the topic Bernoulli equation. We know that first order, first degree, 7 types of methods, and one of them is Bernoulli equation. Like how do we solve these type of differential equation from a particular method? Okay, so let's see what the question says. So consider the ordinary differential equation ty dot minus 3y equals to t square y raised to the power 1 by 2 and y at 1 equals to 1, and then we have to find the value of y at 2. Okay, so first we'll see the derivation of the Bernoulli equation, that how we'll solve a general Bernoulli equation, and then we'll just put up the value of these question, and then we'll just solve the question. Okay, so first we'll just start the derivation for the Bernoulli equation. Okay, so Bernoulli equation, Bernoulli differential equation, general form is dy by dx plus p of x into y equals to q of x into y raised to the power n, where n is not equals to 0 and 1. Okay, whenever n equals to 0 it will be linear, and whenever n equals to 1 it will be linear in y somewhere. Okay, we'll just put the value of y here, and then subtracting these we'll getting a linear differential equation. So we can use the linear differential equation method. So Bernoulli equation where n equals not equals to 0 and 1. Okay, so what we do to solve the Bernoulli equation is we just take the y raised to the power n in the left side, that will be nothing but y minus 1 dy by dx plus p of x into y of 1 minus n, isn't it? And this will be equals to q of x. Okay, now we'll just put the value y raised to the power 1 minus n as a another variable, that is nothing but let we say put as t. Okay, let y raised to the power 1 minus n equals to t, and in that case differentiating this will be getting 1 minus n y raised to the power minus n, and then dy by dx equals to dt by dx. Okay, so from here we'll just put the value of this, and then we'll be converting this differential equation in this form. Okay, where t will be the dependent variable. Okay, so just putting this value, we'll be getting 1 by 1 minus n dt by dx plus p of x as it is into y raised to the power 1 minus n was t, so it is t equals to q of x, and this is same equation. Okay, so this is nothing but this. Now we have this as a linear differential equation in the variable t. So we'll just solve this differential equation in the terms of t using linear differential equation method, and then we'll just put the value of t in terms of y, and we'll be getting the answer. Okay, so in that case this will be nothing but dt by dx plus 1 minus n into p of x into t equals to q of x into 1 minus n. Okay, so this is the method, okay, to just resolve this differential equation, Bernoulli differential equation. Okay, in our question, what was the question? This ty dot is nothing but the derivative of y with respect to t, because t is the dependent variable here, independent variable here. So what is the differential equation? Is ty dot minus 3y. Okay, so our question is the given differential equation, let's say, is ty dot minus 3y. Okay, so minus 3y equals to t square into y raised to the power 1 by 2, and the initial condition is given as the condition is this, y at 1 is 1. Okay, so in our question, the x is replaced by t. So we'll just reverse the process, and we can use this differential equation just to convert this into another differential equation which is linear, which will be linear in that particular variable, but we'll just solve this particularly like in the method above. Okay, so we'll just put the y raised to power half common here. So this will be nothing but y raised to the power minus 1 by 2 into dy by dt, let's say, and then minus 3y raised to the power 1 by 2 is equals to t square. Okay, so this is the differential equation. We'll just put y raised to the power 1 by 2 as t, so let's say x. Okay, so in that case this will be nothing but half y raised to the power this equals to dy by dt, differentiating it with respect to t, no? So and this is nothing but dx by dt. Okay, so y raised to the power minus 1 by 2 dy by dt is equals to 2 dx by dt. Just putting these values in the given differential equation, this is ty dot, isn't it? This ty raised to power minus half, so this will be equals to 2t dy by dt. Okay, and then minus 3y raised to power half, so minus 3 y raised to power half we existed as x, so this is nothing but dx by dt, na? Dx by dt minus 3x, and this is nothing but t square. So what will be t square in that case? T square will be as it is. Okay, so this is nothing but a linear differential equation in x. So we'll just solve this differential equation. This is nothing but dx by dt, just putting these as 3 by 2t, x equals to t by 2. Okay, so this is the linear differential equation. Now we'll just find out the integrating factor and just be solving this. Okay, so in that case our integrating factor will be nothing but e raised to the power this minus 3 by 2t dt. Okay, so this is equal to e raised to the power minus 3 by 2 t integration will be log t. So this is nothing but 1 over t raised to the power 3 by 2, cancelling exponential with log. So our integrating factor will be nothing but 1 over t raised to the power 3 by 2. And for linear differential equation, the solution will be of this form, isn't it? Say suppose if our differential equation is this, so x into integrating factor is equals to the right hand side part, that is q of x into q of t, q of t into that integrating factor integration dt and plus c, isn't it? So in our case x into 1 over t raised to the power 3 by 2 equals to t by 2. Integrating factor is 1 over t raised to the power 3 by 2. Okay, and this is dt plus c. Okay, here we are getting this. Now just we are doing just calculations, nothing else. T raised to the power 3 by 2, and this will be nothing but 1 by 2 t raised to the power minus 1 by 2 dt integration plus c. Just integrating this, we will be getting 1 by 2 t raised to the power half and 1 by 2 over here, so 2 plus c x into 1 over t raised to the power 3 by 2. Okay, so just cancelling this out and they will be getting x equals to t square plus c t raised to the power 3 by 2. Okay, so now we are just converting x in terms of y. We'll back to our original question, will be y equals to 1 by y raised to the power 1 by 2 t square plus c t raised to the power 3 by 2, and we are given with the condition as y at 1 is 1. So y at 1 is 1 is 1 equals to 1 plus c, which is nothing but c will be 0 in that case. Okay, so our y raised to the power 1 by 2 will be t square, which is nothing but y equals to t raised to the power 4. Okay, and we are asked to find the value of y at 2. So y at 2 will be equals to 2 raised to the power 4, which is nothing but 16. Okay, so our answer is 16, and this is nothing but our B option. Okay, so B is the correct answer and A, C and D will be incorrect. Okay, so this was a question from 30th November 2020 and from the part B, which is a single correct question. Okay, so this was somewhere tricky question but easy question. Okay, thank you.